Welcome back. In this video, we're going to start working on section 2.2, which is about solving equations using the multiplication and division properties. So the plan for the section is to look at what those properties are and then work through some examples. So let's start by looking at the properties. So for this, suppose that A, B, and C are any numbers or real numbers and that C is not zero. For the addition and subtraction properties, the A, B, and C could be anything. For this, the C needs to not be zero. Okay, so then if that's the case, what do you get? If A and B are equal, then what do you get? You get A times C is equal to B times C, and then A divided by C is equal to B divided by C. So basically, if two numbers are equal and you divide them by something, you get an equal answer. If you multiply them by something, you get an equal answer. Okay, and then here the restriction is that C is not zero. Of course, if you multiplied both sides by zero, you'd get 0 equals 0. It's just that that's not helpful. The true requirement that you're not dividing by 0 or the C is not 0 comes from the division property. All right, but the overall the takeaway here is that you can multiply or divide both sides by the same number as long as it's not 0. Okay, so here we're going to try it. We're going to solve 3x equals negative 18. So here the unknown was multiplied by 3. So we're going to divide both sides by the 3. And that will make it so that we have 3 over 3 times x, or just x. And then negative 18 divided by 3 is negative 6. So our solution there, negative 6. Okay, we're going to solve 9p is equal to 2. And so again, keep in mind that our goal is to end up with the p by itself. Right now it's been multiplied by 2. Sorry, multiplied by 9. So we're going to divide by 9 to give us p is equal to 2/9. So our solution here is 2/9. Okay, make sure that you're dividing or multiplying both sides by the same amount. Okay, in the next one, we have a is divided by negative 3, giving 12. And so we should multiply both sides by negative 3. And so we'll have just the a on the left side and negative 36 on the right side. So negative 36 is our solution. Here, negative n is equal to 5. For this one, you could look at it either multiplying or dividing by negative 1. Either way is okay. This is the same as negative 1 times n equals 5. I'm going to look at it as a division. We're going to divide both sides by negative 1. Negative 1 times negative 1 will just be n. And then on the right side, we will have negative 5. So negative 5 is our solution. And that will do it. Just for fun, if we had chosen to, we could look at it as being multiplied by negative 1, and we could just multiply by negative 1 again. Right, negative of negative 1 times n is equal to n. So n would equal negative 5 again. So either way is okay. Okay. In the next couple of examples, we have our variable multiplied by a fraction. And so in order to isolate the variable, we'll think about multiplying by the reciprocal on both sides. So we have 2/5 n is equal to 14. And we're going to multiply both sides by a fraction set up in the following way. If we want something to cancel with the 5 that is here on the left, down below, so we'll have a 5 in the numerator. Similarly, the 2 that is next to the n, we need something to cancel that. So we'll be multiplying ultimately both sides by 5 halves. Okay, 5 halves times 2/5 is going to be 1, so that leaves us just an n on the left side. And then 14 times 5 halves is going to be 35. Okay, so just 35 for that. All right, next up, we have negative 9/25 is equal to 4/5 k. And so once again, we need the k to be by itself. So we need to multiply both sides by something to make the 4 and the 5 go away. So we'll need a fraction with a 4 on the bottom and a 5 on the top. Make sure that you're multiplying both sides by the same amount. Okay, 4/5 times 5/4 just equals 1. That will leave us just the solid k on the right side. And then on the left side, we can see that there's a factor of 5 that can be removed. And that's it. So we'll be left with negative 9/20 for our k. So our solution, negative 9/20. Okay. All right. In the next couple of examples, we'll see some equations where some simplification is needed first. Okay, for this one, for the left side, we have 18 minus 27. 18 minus 27 is negative 9. And then on the right side, 15x minus 9x minus 3x. This is the same as 15 minus 9 minus 3 all multiplied by x. 15 minus 9 is 6. 6 minus 3 is 3. Okay, so negative 9 is equal to 3x. And now finally, we're ready to divide both sides by 3. That will give us our x is negative 3. So negative 3 is our solution. In the next example, you can see that we'll need to distribute to remove some parentheses and then combine like terms. So you may want to try this one on your own. Pause the video, try it, and then restart the video and see how you did. All right, so we have negative 4 multiplied by q minus 2. So we'll have negative 4q. And then negative 4 times negative 2 is plus 8. And then minus 8. And that's equal to 24. Okay, the plus 8 and minus 8 add up to 0. So we have negative 4q is equal to 24. And then we're going to divide both sides by the negative 4. And so that will give us q on the left side and negative 6 on the right side. So our solution is negative 6. Okay, so we have more examples to come. Okay, this one again, we're going to need to distribute to remove some parentheses. We'll start by multiplying negative 6 times w, giving negative 6w. Negative 6 times negative 2 will be positive 12. And then in the back, at minus 12, we can see that the structure is similar to our last equation that we solved. And so we'll have ultimately negative 6w is 30. That will make w be negative 5. Negative, what's that? Negative 5, our solution. In the next few examples, we'll see that we can translate. Sorry about that. Zoom crashed on me. I had to restart it. So I'm sorry about that. All right, so I'm not sure how far back that happened. So let me back up just a second. So here we had distributed for this one, negative 6 times w, negative 6 times negative 2. That gave negative 6w plus 12. We had the minus 12 equal 30 all along. The 12 minus 12 added up to 0. Negative 6w made 30, so that w is negative 5. Okay, in the next few examples, we're translating from English to math, and then we're solving. So let's do that. Here it says the number 132 is, and then product is multiplication, the product of negative 12 and y. So we have 132 is negative 12y. Divide both sides by negative 12. So we'll have y equals negative 11. Negative 11 is our solution. Okay, next up, we have n divided by 7 is equal to negative 21. Here our unknown was divided by 7. We'll multiply both sides by 7. So then on the left side, we'll just have n. And then the right side, a negative 147. So negative 147 is our solution. Next one's got a fraction in it. 2/5 of is like multiply. 2/5 of v is 16. Okay, so then here we're going to want to isolate v. So we'll be multiplying both sides by the reciprocal of the 2/5. That will be 5/2. So we're multiplying both sides by 5/2. 5/2 times 2/5 is going to give us a 1 on the left side. So that's just single v. And then on the right side, 16 divided by 2 is 8. 8 times 5, 40. So for this one, our solution, 40. Okay, this one is a sum. Sum is an addition. The sum of 5/8 and x is 1/4. Okay, so this one is a sum problem. So to undo this addition, we'll subtract, right? So we'll have that's x plus 5/8 on the left, and then the right side was 1/4. For this section, I know we're focusing mainly on multiplication and division, but I wanted to throw it in here where we are adding or subtracting, just to make sure that we identify the wording correctly. Okay, so sum was an addition, but that's okay. So now we have x plus 5/8 minus 5/8, that's just x. The right side, 1/4 is the same as 2/8. 2/8 minus 5/8 is negative 3/8. So our solution finally is negative 3/8. Okay. All right, in the next couple of examples, we're doing some applications or story problems. Okay, so here it says a 24 pack of water bottles is $9.36. We want to know the cost of one water bottle. So for this, we have the whole amount is $9.36, and we want to put it into 24 parts, and we want to know the size of one out of the 24. So that sounds like division. We need basically 9.36. 9.36 is the price for 24 bottles, and here X is representing the cost of one water bottle. So to do this, we will divide both sides by 24. So then this will give us X is 9.36 divided by 24. Okay, so we'll have to divide 9.36 by 24. Okay, so 2 would make 48, 4 would be 96. So it looks like 3. 3 times 24 is 72. That will be 1 here and 2 here. 216, that's 9. 9 times 24 is 216. So that's good. Looks like 39 cents each for each of those water bottles. Okay. All right, another example. Here it says Anna planted 14 flats of flowers in 2/3 of her garden. We want to know how many flats would be needed for her whole garden. So the 14 flats is 2/3 of the amount needed for her whole garden. So 14 is 2/3 x. So then in order to isolate the x, we're going to need to multiply both sides by 3/2. And so we'll have 21 for our x. She would need 24 flats. Sorry, 21 flats. Okay. For that one, you can kind of confirm by a picture, if you like. We saw that 2/3 of her garden was 14 of those flats. That means that each 1/3 would have been 7, and so it would take another 7 flats to finish out that remaining third. Okay. Last set of examples for these. There's no story problem or anything. We're just solving equations. So let's try these. We have 8x is 56. We can divide both sides by 8 to get x is 7 for our solution. Okay, and then here negative 9x divided by negative 27. We'll divide both sides by negative 9. That will give us 3. Let's try one with a decimal in it. So here we have 0.75a is equal to 11.25. Okay, we're going to divide both sides by the 0.75. So our a is, when we leave the spot here, we do the math, that's 1125 divided by 75. Okay, and 2 would make 150, that's too much, so we'll have 1, that's 75, that's 7375, and let's see, 2 is 150, 4, 5, 375. Okay, so it looks like it is 15. Okay, and then let's try 89 next. Here we have x divided by 4 is 35. X is divided by 4 to make 35, so we're going to multiply both sides by 4. So we'll have 140 for our x. So a few examples. Okay, we have a few more examples to try. In the next few, we'll see that we have to do a little bit of simplification first. So let's see what we can do. Let's take number 114 first. So here's the equal sign right here in the middle. We have negative 18 minus 7 is negative 25. And our equal sign, we have 5t minus 9t, that's negative 4t. Negative 4t minus 6t is negative 10t. Okay, now we're going to divide both sides by negative 10. And so we'll have t is equal to 5/2, or 2.5 if you like a decimal. Okay, let's try 117. Okay, so for 117, we are going to combine like terms again. 0.25d plus 0.10d is 0.35d. Okay, on the right side, we have 6 minus 0.75. That'll be 5.25. And so dividing both sides by 0.35, we'll have d is equal to 525 divided by 35. Okay, in the interest of time, let me use a calculator for that. That'll work out to be 15. It's our second one that was 15 today. I think it's a conspiracy. Just kidding. All right, so let's try one more. Let's do one with decimals in it. Let's try this one. We have negative 10x minus 40 minus 19 is equal to 85. Distributed to remove the parentheses. And then we'll combine like terms. Negative 10x minus 59 is equal to 85. And then we'll need to, did I do this right? Negative 10x, 40, 19. Okay, so for this one, the reason I paused here for a second is that most of the examples that we've had so far have only needed one operation to really solve. This one is actually going to need two. And most of these are in a later section, so that's why it gave me a hesitation. Okay, so, but that's fine. So we've distributed to remove the parentheses, and now in order to get the x alone, two things have happened to x. And as I said, we'll do more of this later, but first it was multiplied by negative 10, and then we subtracted 59. So to undo that, our first step is going to be to add 59 to both parts. Okay, so that'll be negative 10x, and then on the right we'll have 139, 144. And so x will be negative 14.4 after we divide through by that 10. If you were a little put off by this one, the fact that there were two operations to finish it, rest assured that we'll do more of this at a later date. Okay. Okay, so now we have some more that are in words, and we're going to turn those into math and then solve. Okay, so here 187 is the product of negative 17 and m. So 187 is negative 17m. So we'll divide both sides by negative 17. Okay, so then let's divide both sides by 17. That's 11. So it looks like m is -11. Okay, and then let's try 148. H divided by -13 is equal to -65. For this one, in order to get the h alone, we would multiply both sides by -13. So h will be -65 times 13. And so that is 845. And then what else would be fun? Okay, let's try 154. 154 says 5/6 of y equals 15. So if 5/6 of y is 15, we're going to multiply both sides by 6/5. Okay, so that the 6's and 5's will divide out on the left side, leaving us only y, and the right side will have 18. Okay, let's try 160 next. The difference of p and 1/6 is 2/3. Okay, so again, with this one, no multiplication or division is needed. We need actually addition to answer this question. So we're going to add the 1/6 to both sides. 2/3 is equal to 4/6. And so 4/6 plus 1/6 will be 5/6 for our solution. Okay, kind of an interesting mix of questions here, but we're almost done. Now we have a couple of story problems to do, and then we'll be all finished. Okay, so let's try 162 and 164 and 166. Okay, let's do those. Okay, so for 162, it says Connie's kindergarten class has 24 children. She wants them to get into 4 equal groups. We want to know how many children will be put into each group. So whenever you have a whole amount of something put into groups or chunks of equal size, that sounds like division. So for this one, it's really more arithmetic than algebra, I think. So 24 is going to be or C, I guess. So I want to write this as algebra. So the 24 kids put into 4 groups. That means that there will be C in each group. We'll divide both sides by 4 so that C will be 6. There has to be 6 kids in each group. All right, let's do 166 next. Okay, so here it says Nancy used 14 yards of fabric to make flags for 1/3 of the drill team. We want to know how much will be needed for the whole team. So the 14 yards is the amount needed for 1/3 of the whole team. Call that the X, the amount needed for the whole team. So if 14 is the amount needed for 1/3 of the team, a little thinking will tell you that it will be 3 times as much for the entire team, right? And so 3 times 14, 42 yards for all of it. Okay. And then lastly, 164, Molly paid $36.25 for 5 movie tickets. We want to know the price of each ticket. So the whole amount is $36.25. That is the price of each ticket times 5. Let's say T for ticket. So then to get the amount for 1 ticket, we're going to divide through by 5. Okay, so we need 36.25 divided by 5. It looks like 7.25. Okay, all right, so that takes us to the end of this section. To summarize, we saw that you can solve equations by multiplying both sides of an equation by a non-zero number or divide both sides of an equation by a non-zero number, and that won't mess up the equality. As with the addition and subtraction sections, we saw that sometimes you need to translate from words into math, or sometimes you need to simplify one or both sides of the equation first by distributing to remove parentheses and or combining like terms. We saw that equations sometimes have whole numbers, sometimes they have decimals, sometimes they have fractions, but the methods used are the same. All right, so that takes us to the end of section 2.2. Let me know if you have any questions and have a great day.